Okay, so welcome to part 2 of our tutorials in 242 for modeling topography. The next part of this tutorial is going to represent the next step um, in our first part of the assignment for this workshop, which will be to create a 2D laser contour file from the 3D model. And this is, as if we were taking this little bit of topography and we wanted to make a physical model out of it, stacking cardboard or something like that on the laser cutter. So what I want to do first is I want to adjust it to the scale that I need to use in order to make this model. And if you remember back in our original video, we drew a rectangle that was 24 by 24 inches at 1/128th of an inch. So what we're going to do is we're going to scale it down so it fits into that 2-foot window. So what I'll do is I'll make a copy of this. Again, we don't want to mess up our original model that we're using, because that would be the right 3D model to use when you were working on your design, say if this were for a studio project. But then if we wanted to go ahead and turn that into a model for laser cutting and fabrication, we want to first scale it to the actual size that we're going to make it at. So what I'll do is I'll select the copy I just made, and I'm going to type in scale. Now there's two steps we need to take here. One of them will be to set it to the scale we actually want. And I'll just click on the lower corner there. Doesn't really matter where we click in terms of the center of that scale command. And then I'm going to type in my scale factor. So I'm going to type in the command line 1 divided by 1/28. And so now this model is 1/128th of what it was before. Now, what's important to remember, this is still not the right size, because now it's 1/128th in feet, right? Because our model's in feet. But our actual physical model that we would want to make would be 1/128th of an inch equals a foot. So we still have to scale this one more time to go from feet to inches. And in order to do that, we're going to type in scale again and press enter. Again, click really anywhere to set the center of our scale. This time we'll type in 1 divided by 12. And again, that'll make our model go from feet to inches. And so now if I were to measure one edge of my model here, so we can see it's 2 feet. And that's exactly what we wanted. We want a 2-foot by 2-foot square, right? Okay, great. Now, I actually find it useful at this point to transition to a different file, or transition into inches, because most of what we'll do from this point on will be in inches. So I'm actually going to export this file and into another Rhino file so I can start to work on it in inches. In order to do that, I'll just select the objects there. I'll go to File, Export Selected, and then I can go and save that file. I'm just going to save it as a Rhino 6, and I'll just call that my scale topography. Okay, and then I'll go and open that file. Okay, so here we are. I've opened up that file that I just saved. And again, we just want to confirm we have our 2-foot by 2-foot square there. Now, because I exported it from that other file, my units are still in feet. You can also see if I look over in the layers panel, I just have those 2 layers. So I just have these objects in my file now. I don't have the full scale stuff. And the first thing I'm going to do is I'm going to put my model into inches. So I'll type in units in the command line. I'll change my model units from feet to inches. And I'll click OK. It's going to ask me if I want to scale my model. So right now, basically, like this is a 2 by 2 square. So I want to hit yes, because that'll make it a 24 by 24 square, right? And if I'm in inches, that's the same, right? So I'll click yes. Now might have to zoom out a little bit. Can't find my model. If you can't find your model, just type in select all, zoom, and then selected. Here's my model. You may also find it useful at this point to move your model back to the origin. This isn't that important, but it actually, Rhino can actually start to do some weird things if your objects get way too far away from the 0, point. And you'll also find it useful when we go to print, when you want to make a laser cut model. So I'm going to select all my objects. I'm going to type in move, snap to one of the corners, and then rather than just clicking somewhere, I'm going to move it to 0, 0. In other words, 0 in the x dimension, 0 in the y dimension, or the origin of the file. And there it is. Again, you can just type in zoom selected. All right, so there it is. It's at the origin of our file. And just to confirm, it's 24 by 24. Great. Okay, so now we're ready for the next part of this modeling process, which would be to actually create some contours so that we could make, a stepped representation of this surface as a physical model. Now, one thing that's going to make this a whole lot easier, we're going to make contours through the surface like we did at the end of the last video, but we want to first make it into a solid. So when you make a topography model this way, you're basically going to stack up pieces that are cut out to be the size of the contour, but we're also going to kind of have a base, right? So we need to figure out what's the thickness of the base between the lowest point and the bottom of my model. What's the step size for each layer, and then what are the extents in this direction, right? Because if we were to contour it now, we would just get one line that goes through that surface. So in order to kind of figure all that stuff out for us before we go to make the contours or make the individual segments that we would stack to make the topo, we'll just make our surface into a solid. So in order to do that, I'm going to extrude this window, this outline that I've created. So I'll just type in Extrude Curve. Again, it's a closed outline, so I'm getting a closed surface there. And you do want to make sure that the bottom of it is lower than the bottom of your surface. So another way to do this actually would be to select the surface, type in bounding box, and bounding box will make a surface around your object at the extents of the object. So this is now touching the lowest point of my model and the highest point of my model. And what that allows me to do is to calibrate exactly how thick the model would be below the lowest point of the actual surface. So for example, I could then scale this in 1D, scale 1D. I'm going to snap to the center point of one edge of that bounding box. I'm going to make it both taller and higher and lower than the model. Right? And then I'm going to add a certain dimension, right? So if I know, for example, I'm going to draw a line here from the midpoint to the end point. And if I measure the length of that line, I can see it's 3.22 inches. Let's imagine for a moment that we're making a model that has out of 1/8 inch contours. Say we're using corrugated cardboard or something like that. So we have a kind of a 1/8 inch step size. So let's say I wanted to extend below my model 1/8 of an inch in order to make sure I have at least one layer that's a full solid layer. So I have a solid base to my model. So I could extend that line. Oops, I'll just type in extend. I'll click on the curve. Make sure you click the curve and not the edge of the poly surface. And then it'll ask me end of extension or extension length. Again, we want to extend by 1/8 of an inch. So I'll type in 1 divided by 8. Press enter. And so now that line is 1/8 of an inch below, and I can scale my bounding box to that. Sorry, scale 1D, go from the midpoint of the box to the bottom, and then snap to that line I just extended. Easy enough. Okay. So now I have a box that's, going all the way around my model. Again, because I used this window when I originally trimmed my topo surface, I know that that box is going to be a square kind of in top view or in the XY plane. And then I'll take that 3D surface, I'll select it, I'll type in trim, and I'm going to click on the box that I just made. And sure enough, it does not work. So there's a couple things we can do at this point. One of them is we select both those objects, we can type in intersect. And so we can look at places where, for some reason, my model is not touching. Not exactly sure why that would be. It could just be kind of a weird tolerance issue when I trimmed the surface originally. There's a couple things we can do to fix this. So I still have my curve. Oops, I don't have my curve. I'm going to go back a couple steps so I have my curve there. And I'm going to try and trim it instead by extruding this window. And then scaling it to the bottom of my curve there. See if that works. So I'll select my surface, type in trim. Okay, so that did work, even though the bounding box didn't. So that's one solution. If we go back a couple steps again, and I go bounding box, again, so this wasn't working, right? The other option that we have is we could actually untrim our original surface and retrim it to this box. Now the command to do that, and I just hid that box, so I still have it in my file. I'm going to type in untrim, and I can click on any open edge of my surface, and it'll take me all the way back to when I originally, all the parts of that surface that were there when I originally created it. Then I'll type in show to bring my box back. But then I can actually trim the surface again using my bounding box. And so now I know they match, and if I use my surface to trim the box, it should work. So that's another way to solve that problem. And again, the bounding box was based on that low point of this curve, so we know it's at least 1/8 of an inch below. So now we have a model with a base, and I'm going to go ahead and join these together, and we should see that it joins into a closed polysurface. That's not super important, but we want to join it. That'll simplify the lines that we're about to make. And so we're ready at this point to make a series of contours that would represent our steps if we were to make a physical model of this topography. Just like I did in the last video, I'm going to select the object, type in contour. I'm going to choose a base point. Now remember, the offset of the low point was based on that curve that we extended. So I'm going to make sure I click on the bottom of this base that I created to set the start point. And then it's going to ask me direction I want to go. Again, I always want to go vertical to create horizontal contours. And then it'll ask me the distance between those contours. And now I've already made the decision that I'm working at 1/8 of an inch with my material. So I'll type in 1 divided by 8. And there we go. So now we have a series of lines that represent each layer that we would want to cut out to make a stepped topography. I'm going to go ahead and move those to one side here real quick. Actually, I copied them. And then what I want to do with this here, just to kind of see what my model would actually be, is I'm going to extrude. I'm going to select all those lines, and I'm going to type in Extrude Curve. I want to make sure the option solid is set to yes. And then I'm going to type in 1/8 of an inch, which should be the exact distance that created each of those contours. And so there we have it. So that should kind of give us an idea. And I'll put it in rendered so we're not seeing the edges there. Should kind of give us an idea what our model would look like with those made out of those like layers out of those steps. Okay. So what I'm then going to do, the very last step I would take if I wanted to actually make this into a model would be to lay out these pieces, right? I need to actually lay them out so that I can cut them out of individually out of whatever material I'm using. In this case, we're assuming that 1/8" cardboard. So I'm going to go back and select my original lines one more time. I'll deselect the surface there. I'll deselect the boundary. Deselect that curve. I'll make one more copy here. Again, I'm going to go to the right. And so I want to lay out these curves. Now, I didn't really mention this before, but like I said, the reason that we made that that original surface a solid is so that each one of these curves is actually joined already with the boundary of our model, right? So that saves us the step of having to create a closed outline in order to create a full cut path if we were to take these shapes to the laser cutter. So what I would actually have to do if I wanted to cut this is I'd have to actually take each piece and lay it out so I can position it on a piece of material and make a series of cut files for each of those pieces. And that means I have to actually move them all, right? Now there's an easy way to do this with a contoured model that'll save us a couple of steps. So if I select all these outlines one more time, I'm going to go into front view. I'll type zoom selected so I'm right there on where my model is, those lines. And I'm going to use a command called shear. This is kind of a shortcut. So I'll click on the bottom lower left corner there because I'm going to move them out to the right that way. And I'll draw a line straight up. I'm holding shift and I'm going to make sure I'm not snapping to anything when I set this second point. And I'll click somewhere up there. And then I'm going to drag my, I can actually go back into top view so you can see what I'm doing here. I'm going to drag my mouse over to the right. You might have to actually, but you can see what I'm doing here is I'm separating them. Do it in side views, as you see. So what I want to do is I want to go far enough that every single layer is going beyond the previous one. Okay, and then if I go back to top view, you can see I've just laid them all out equally spaced in sequence so that I could, then go and start to position them in my cut file. And because these curves are totally horizontal, and I sheared them based on a center axis that was totally vertical, I didn't distort them at all. I just moved them apart from each other. So that's a really useful kind of quick trick for laying out models that are based on contours. So I'll go into top view now. The very last thing we want to do, just to kind of make sure we have everything set up right, would be to make sure everything's on the XY plane. So I'm going to then take these outlines, I'm going to type in the command project to C plane. So what that'll do is it'll project it to the plane of whatever viewport I'm in. So basically 0, 0 in the Z axis. Delete input objects, I'm actually going to hit yes because I don't want duplicate objects. And then it went and did that. So now if I go Control Z, you can see those were each stepping up. So they were still at different heights. They were just separated horizontally. And if I redo it, you can see they're now at 0. They're all laid out on the 0 plane. Okay. Go back to top view again. And then what I would do before I even start to lay these out on a sheet of material or anything like that is I would actually go in And I would do two things. I would make myself a reference. So what that means is when I want to put together this topography, let's say I cut out all these pieces and I'm trying to glue them together now and make sure they're lining up right. For the most part, it's pretty easy because I have a bunch of outside edges to line up, right? But when I start to get to some of these, so for example, a shape like that, right? How do I know exactly where that's supposed to line up on that piece, right? I don't have any outside reference for where that line is meant to hit that piece. So I'm going to go ahead and make a new layer, a couple new layers actually. I'm going to make a layer called cut, and I'm going to make a layer called score, and I'll make them different colors so I can kind of see what I'm doing. The cut layer is going to be blue. My score layer is going to be red. Okay, so I'm going to go back to top view and I'm going to put all of these outlines on a layer called cut, on my layer called cut. So I'll go change object layer. Now they're all blue. Now, so speaking of that issue that I was just talking about, I could then copy these to each other in order to figure out, and then score that line in order to figure out where each one lines up on the previous. So what I'm going to do is I'm going to select all my outlines based on, starting with the first one over from, or the second one, I should say, starting with the second one. So I'll select all my outlines. And again, remember, because we sheared them, they're all evenly spaced apart from each other. I'm going to type in copy. And then I'm going to copy these so that they overlap the previous. Then I'll click to deselect. And then before I do anything else, I'm going to type in select last. Select those objects that I just copied, and I'll move those to the layer score, change object. And so now you can see when I cut this piece out and I score, if I were to score that line on this piece, I would end up with a mark on that piece scored that would indicate exactly where that edge is supposed to line up. And again, when we get over into pieces like this, right, figuring out where that guy is lining up on that guy is going to be really, really helpful. So you could delete those for ones, like you could go in and delete for ones that you think you don't need them for, because I'm just lining up to that outside, which would save time on your cut file. But anyway, so that's a little trick for lining things up. And then the other thing I would do before I got too far is I would label these, because when you cut out however many odd pieces, maybe we have 50 pieces here or something. It's going to be hard to keep track of which one is which and which order they go in if we don't label them somehow. So I would make another layer, and I'm going to call this my labels. I'm going to make that a separate color. Again, I want to cut these labels, right? I'm going to use the laser cutter to engrave them onto my pieces, but I want to make sure that they have their own, I can set up that engraving process to its own settings. And then I would go ahead and I would type in text, and I might go, well, we probably have more pieces than what we can do with the alphabet, so I'll just start numbering. And so I'm just going to click somewhere in there. First of all, I should have made that labels layer my current layer, so I want that on my labels layer. I'm going to go ahead and place that in there. And then I could do that with each one, and I could number it. I like to do O2 just so I don't get confused about whether I'm missing some information. And again, I'm going to just cut them, or I'm going to position them so that they're in a place where, when I cut out this piece and I engrave 3 on it, once I go ahead and glue this piece on top of that, I'm gluing over that engraved marking, right? So I'm not going to see that when I actually assemble my model. And so I would go one bit at a time. And I'm not going to obviously do them all because it takes a while. And then maybe when I got over to these ones where I'm starting to get multiple pieces on the same layer, let's say this is layer 20. I might go 20A and 20B. So I know those are both the same level, but they're two separate pieces, right? And I could go 20A or 23A, B, and C if I wanted to. Some of these have 3. And then the final step you want to do, once you're done labeling these, is I would actually then take those text objects that I just created, and I'm going to type in explode. And when I explode a text object, you can see it actually turns it into outlines. And so I would just tell the laser to go in and engrave that outline in order to label each piece. And when you do explode a text object, it no longer becomes editable. So I'd have to make a new text object. If I labeled this wrong, I'd have to make a new text and explode it instead. But that's the best way to kind of engrave your labels on your pieces. Okay, so once you kind of had that stuff all done, what I would do would be I would go and I would make a layer called material. So a couple things. We know the printer bed of the laser cutter is 18 by 32. Oops, 18 by 32. I want to look at that like this. And then I would also make a rectangle that represents the size of my material. Let's say I have that 1/8" cardboard, and they're cut to certain sizes. So I don't know what I would depend how I wanted to cut up my sheet. But if I had like 24 by 32. Oops. Oh, well, that actually brings us to a good point, which is that you wouldn't be able to fit one of these onto a laser cutter, onto the laser cutters we have at school. So, so that's something to keep in mind before you start figuring out your model. Of course, we could actually go in and like start, separating these into slices so that we could do them in two separate pieces, right? But anyway, so there's something to consider. So once we had I would draw the laser cutter bed. That'll help you line it up when you go to print it. And then I would also draw the sheet size, and I'm going to put that in a layer where I have a color that I'm not printing that line, right? I'm just using it to line up where my cut's going to go and where I put my material in my bed. And then once I get further on down the line and I'm cutting some of these smaller pieces, I can start to, and again, I've already got them all individually labeled, so I can keep track of them once I cut them. And I'm putting a bunch of pieces into one layer. And you can spend as much or as little time as you want nesting your cut pieces onto a sheet. This step will not be required as part of your submission, so you can leave your file laid out just like that. But anyway, so then you would go in and start to create independent sheets and lay all your pieces out onto those sheets. Figure out how many sheets you need, cut them all to the right sizes, get all that stuff ready before you go down to your laser cutter appointment and start making this model. Okay, so that's going to be, again, that's the extent of what we'll ask of you in this tutorial. So what we want to see will be the 3D model of the surface, the steps, and then the cut file. So this will be the Rhino file that you submit. You don't have to label everything. That seems like an unnecessary use of time. But we want to see all the cut pieces laid out like so. So you'll submit this Rhino file, and then please also submit the original PDF where you got your topography from, and find some way in here to go ahead and kind of call out for us. Oh, where's my road there? So you can do this in Rhino. You could keep the keep the PDF in your Rhino file, or you can submit the PDF separate and just draw like a rectangle for us of kind of where your topography is. So save that. I would save the PDF with that rectangle, so that we can refer back to kind of which area you drew your topography of, and then submit that. So submit a PDF, what you originally downloaded, with the rectangle of where you drew your topography. The other way I could do that would be to open up, I'm going to save this really quick. If I were to open up the original file, the full scale file that we worked from, which remember has our PDF in there, I could then, let's see, I'll turn on my layer. And I would probably turn off my surface. The best way actually might be to go ahead and just make a quick layout. Oops. In inches. So I'll put my units of my layout in inches there. Make a layout. It can just be 11 by 17 or 8.5 by 11, whatever you prefer. Obviously this is portrait. And then I would just kind of lay that out so we can see and print that PDF for us so we can see where you drew your topography from. Okay, and those will be the 2 files that you'll submit for this workshop on day 2, at the beginning of day 2. All right, that will be the end of this video. I will sign